Find the relation between X and this L. Find X in terms of L. I think it's a equilateral triangular tube. The liquids are filled up where the densities are like this. You have to get the relationship between the X and L, that one. So shall we proceed directly? Pressure at 1 or pressure at B should be equal to pressure at C. Now, what is pressure at B? Due to LHS of the liquid column, and pressure at C due to RHS liquid column. This will be 60 degrees. Pressure at B should be equal to rho plus 2 delta G. There should be height X sine 60 degrees plus rho G. This will be L minus X sine 60 degrees. Pressure on the due to right hand side of liquid column, it should be equal to rho plus delta L minus X sine 60 degree plus rho into G X sine 60 degrees. So G sine 60 degree will get cancelled out. So rho plus 2 delta rho L minus X is equal to rho plus delta L minus X plus rho X. So we have to solve all this total equation and we have to get expression for X in terms of L. Anybody? Just check the calculations. So is that okay? No. So this is the length. It's the incline. No. It's projection. How much it will become? X sine 60. Then what is this length? L minus X. Its projection will be L minus X sine. Vertical projection will be L minus X sine 60. Pressure depends only on depth. That like that we are writing it. Rho X will get cancelled out. You can check it. You can select it. Something I rho plus 2. First one, how much? Rho plus 2 delta. Yeah. Anybody value?
X is L by 3.
X equal to L by 3. It's a device, a very famous device it is. Of course, we are not learning how to use that one. Just one small basic diagram I gave that one. This will be best, easier method, no? So how to fill up a liquid. I'll get a small hole. I'll make it a small hole here. First, I'll fill up a liquid like that. This one, X equal to L by 3. So did I put them all three in equal volumes? Definitely no. Looking at the diagram, all the three liquids are filled up with equal volume. So you can see from the diagram itself. So any liquid whose density is unknown, we are going to find out. Like that, what happened? We have designed some around 180 different instruments are brought. Each one is having its own advantages, disadvantages. This was the thing what they were using to measure the pressure, to have the density of a liquid. Where do we use all this? What is the use of knowing density? If you go for pharmaceuticals, especially to manufacture the syrups or the tablets, no? So we need the density of material. What shall I do? I use these equipments. So just if you go back 30, 40, 50 years, no? So these are the only instruments, especially in pharmaceutical, biochemical, fertilizers,